utilization. So what is it exactly? All right, IPC talks about carbon sequestration as being a storing of carbon in a carbon pool. The U.S. Geological Survey says it's an anthropogenic process of capturing and storing atmospheric carbon dioxide, and you'll find definitions of it all over the place. I am using it in this presentation as an umbrella term, okay, for all of the different carbon sequestration technologies. So there are three anthropogenic carbon sequestration terms I want to go through. The first is carbon dioxide removal, CDR, which is probably the one you hear the most. And it is defined as anthropogenic, of course, in removing carbon dioxide from the atmosphere and storing it securely. And some examples, one example would be direct air capture and storage, and using a specific example that's being used in Iceland right now, where they take air from the atmosphere, okay, run it through fans, then it's either absorbed or adsorbed by a material. And absorbed you can think of as like a paper towel that absorbs moisture, whereas adsorbed with a D is where the molecules are sticking to the material, and then they reclaim the CO2, they inject it into basalt in this case, and it is hardened very securely, as almost like a crystal, into stone. Now the next one is rather controversial, enhanced oil recovery. This would only be defined as CDR if the CO2 originally comes from the atmosphere and it is durably stored. In the United States, oil companies are taking advantage of some of the tax credits by actually producing additional oil, which of course increases the fossil fuel use on this. This is something that they've known that would work, injecting CO2 into a reservoir, and it helps bring the remaining oil out. So, but again, it's only considered CDR if it's atmospheric and it is durably stored. So there's a specific term, and this is the second term, for when you're using an industry material stream, for example, and what you're doing is separating CO2 from the stream, okay, and then transporting it to a location and long-term isolation from the atmosphere. The third term is carbon capture and utilization, CCU, and this is rather interesting. What they do is they capture the CO2 and then they turn it into a product. And again, this is very expensive to do, but so far some of the things that they've done is convert it to gaseous hydrogen and solid carbon, which could be then sold, or to carbon nanofibers, which could replace steel, for example, for making parts, and an additive for concrete. And who knows what else might come up with it. I've summarized these terms here on this table to make it easier for you. This is, again, anthropogenic carbon sequestration terms, and you can see the difference between them. Now let's talk about anthropogenic assisted natural carbon sequestration terms. This is called negative emissions technologies, and it is when humans come in and they assist the natural process of carbon sequestration. So here are some examples, and there are many here. The first is afforestation, which is planting trees where they have not been before, and reforestation, which is reestablishing forest. Believe it or not, most of the carbon sequestration that's taking place today is through this process. And it's very, very tiny. We really have to get ahead of the game. No-till farming. Whenever you till the soil, you're releasing carbon dioxide into the air. Conversion of biomass to biochar. They burn it, It's supposed to be a dead animal there with the upside down. I'm into petroglyphs, and I know that's how they represent if a person has died, they put them upside down, so I was trying to think how to do that. Any case, they burn it, and then they put the biochar into the soil, and it's for agriculture. Then adding iron to the ocean is helpful. It encourages, it says, biological activity to pull CO2 out of the air. I've got a caution sign here because there may be some unforeseen consequences of this on the biology in the ocean. Enhanced rock weathering, the fifth one. Before I tell how it's enhanced, let me talk about the procedure, the natural procedure that takes place. CO2 combines with water to form carbonic acid and comes down as what we commonly call acid rain, right? Falls on rocks, and depending on the type of rock, you're going to have reactions. This type is here calcium carbonate, which I'm using as an example. So that combined with the carbonic acid leaves you with carbonic ions and bicarbonate. The bicarbonate is then, or the rock rather, breaks down. It goes into lakes and rivers and eventually makes it to the ocean, where it then breaks back down into CO2 and water. The CO2 is heavier, it sinks to the depths of the ocean where it is stored. Excuse me. Now, how is it enhanced if when mankind, or womankind, or humankind comes in, to be perfectly fair, is that they take rocks and they crush them up into a fine powder, or you take clean mining powder waste and you sprinkle that over the soil. By the way, there's this is supposed to, oh, thank you so much. I am losing it there. And that enhances it in that it breaks down much faster. Excuse me. The sixth one is bioenergy with CCS. Everyone remember what that is? CCS, carbon capture and storage. You take your biomass source, and I've listed them here. You convert it to energy in 4 different ways. Well, one of them is kind of overlapping. You burn it, okay? You convert it to a fuel, and it can be converted to fuels biologically, chemically, or thermochemically. And for all of those, what you do is then pick up the capture the CO2 when it comes out of the stack, when it's being used to create energy. Okay, so now this is just a simple, quick side on transportation and storage. Transportation of CO2 is being done and will be done in similar ways that other energies, fossil energies, have been transported, as shown here. There is some concern about leakage. There's also the sequestering can be done by injection into geologic formations, deep levels of the ocean. By the way, I had read one source that said that they didn't think that was still viable, but I recently read that the UK is trying that as an option. Mineralization into rock, as an example, I showed you with the direct air capture, for example, in Iceland, and conversion into a product. The concerns for the first 2 possible storage, there may be some leakage, and who knows? It's to be determined. There's too much to cover in such a short time in this. So what are the challenges? Well, the challenges are great. First of all, let's look at cost. And I've listed some of the cost here. On the left, we have the 2023 listed cost. Let's look just at afforestation and reforestation, for example. $5 to $240 per ton. That's per ton. If we want to get rid of 1 gigaton, add 9 zeros behind these numbers. I'm pausing because I want you to realize the gravity of that it's extremely, extremely expensive. If you go down to direct air capture, which is the most expensive, $100 to $345 per ton CO2. We think of 420 parts per million being a lot of carbon in the atmosphere. Well, parts per million. There are very few atoms, or excuse me, molecules in there relative to the total air, right? So you have to pass a lot of air through there to pick it up. I thought it was interesting, and I can only get 2019 values for the ones on the right. Industrial processes where you have high concentrations of CO2 streams, $15 to $25. You'll see that the upper limit is lowest here. So that, it looks like one of the more economical, if you can call this economical, processes that can be done. So that's the cost. The cost is extremely high. We have some potential safety issues, and how do you store it? What about the capacities that we have right now? They're really lacking. Carbon capture, utilization, and storage facilities, I'm reading a quote, currently capture more than 50 million tons. A reminder, million tons is 5/100ths of a gigaton. And global emissions for 2023, where I said earlier it was just under 60,000 gigatons per CO2. So we're a long way off. Total amount of CO2 that could be captured, these are all quotes in here, in 2030 would be predicted 435 million tons, not gigatons, million tons per year, and announced storage capacity of around 615 million tons of CO2 per year. And we are drastically lacking the potential capacity at this point for that. So let me talk specifically again about direct air capture. You need 300 times the volume of air to go through to capture the same CO2 that you would from a stream of, heavy CO2. The IEA net zero emissions by 2050 scenario, direct air capture technologies capture more than 85, again, million tons of CO2 in 2030, and around 980 million tons in 2050, requiring a large, and underlined it, an accelerated scale up from almost 0.01 million tons today. So currently, there are 18 direct air capture facilities operating in Canada, Europe, and the United States. The first large-scale direct air capture plant of up to 1 million tons per year is in advanced development and is expected to be operated by the United States by the mid-2020s, unquote, and this is from the IEA. In summary, the IPCC has stated that carbon capture and storage must be paired with decarbonization to limit or return to, if we overshoot, and it certainly looks like we may overshoot, the 1.5 degrees centigrade or the 2.0 degrees centigrade above pre-industrial levels. Carbon sequestration, as I've emphasized here, is extremely, extremely expensive. And it's also energy intensive. That's why the operation going in Iceland is so good, because they can use basically nearly free energy, for the geologic energy. There are concerns about safety, and the projections of capacity seem to be off. And in conclusion, I want to share these two recommended sources. I will leave these on the screen, although I think you will get copies of the presentation. The first is an IEA database, which shows everything that's going on, or has been going on since 1970. If it has an announced capacity of at least 100,000 tons per year. And the Smith School of Enterprise and Environmental at the University of Oxford has a free data portal on the state of carbon dioxide removal. Thank you so much. You've been a great audience.
I think we have time for one or two questions, if anyone has one. No?
I didn't mean to make it depressing. We're talking about climate change. It's really hard. Thank you.
Thank you. Please use Slido, last Slido for this session. Thank you very much.